Hey guys, welcome to solving quadratic functions by graphing three different ways, 8.8. So we're going to solve them three different ways. First thing that you can do in solving a quadratic function is to graph the x squared plus 2x minus 3. So when we graph this, negative b over 2a is how we find the axis of symmetry. Negative 2 over 2, negative 1. Because this is a 1 and that's your a value. This is a, b, c. Good deal. So we know that our axis of symmetry is at negative 1. Now we plug in that negative 1 to find where our vertex is. 1 times negative 1 squared plus 2 times negative 1 minus 3. Negative 1 squared is 1. 1 times 1 is 1. 2 times negative 1 is negative 2 minus 3. 1 minus 2 is negative 1 minus 3 is negative 4. So we're down here at negative 4. Okay? So now we want to probably go ahead and plot our y-intercept, which is up 1 over 1. And we could always go over 2 and up 4, which would be there and there. That would lead us to believe that the solution is x equals 1. And x equals, this is negative 1, negative 2, negative 3. X equals negative 3. Okay? So we could plug those in and check them. If we plug in negative 3 squared is 9, plus negative 3 times 2 would be negative 6, minus 3 is 0. So we do know that this solution, x equals negative 3, is one of the solutions to this quadratic. Now if we plug in 1, 1 squared is 1, plus 2 is 3, minus 3 is 0. So now we've proven that that's also a solution. Okay? So that's one way you can graph them, is to graph in standard form, and then just extend the graph to find your zeros where it crosses the x-axis. Another situation here is graphing negative 3x squared plus 6 plus 1. On this one, I guess we could go ahead and just do the negative b over 2a, negative 6 over negative 6 equals 1. So we know our a of s is at 1 again. Find the vertex, plug in 1, so it's negative 3 times 1 squared, plus 6 times 1, plus 1. 1 squared is 1, times negative 3 is negative 3 plus 6 plus 1. Negative 3 plus 6 is positive 3 plus 1 is positive 4. So my vertex is at 1, 4. So we go up 1, 2, 3, 4. And now again, just as you've seen with vertex form, it goes, well actually this one will go a little bit steeper, just because that negative 3 there. We could go ahead and we can estimate this is a 1 that intersects the y-axis. And on this kind, I'll be honest, you have a stretch of 3. It crosses the y-intercept at positive 1 because of the c value, So it's going to be a fraction down in there that it's crossing the x-axis at. And I'll be honest, I would put that into a graphing calculator and run my trace buttons over it. And I would graph it as y1, and just go ahead and put this in, negative 3x squared plus 6x plus 1, graph that one. And on y2, I would graph 0. And then take my trace button and find where they intersect. Okay? Now we have a situation. We've got, somebody standing on a 48-foot platform kicking or tossing something off. Looks like a parabola. Just by the U shape, that's the nice thing is usually we get parabolas when we drop things or propel them out. So we have the formula here. It's always negative 16 t squared because that's for gravitational force. Vt is our velocity that something's thrown. Ho is the initial height. So the velocity it's thrown is 8 feet. That'll go in for the V. The height at the beginning is 48. Now I went ahead and worked this out. So I divided everything by the negative 16 because I want to get rid of the negative on the front and, not negative 16, negative 8. Because I wanted to get rid of the negative off the front. You don't ever want to factor with that. And I didn't want the numbers so big. So I divided 0 by negative 8, I got 0. Negative 16 by negative 8, I got 2. 8 by negative 8, I get negative 1. 48 by negative 8, and I get negative 6. Then that's easily factorable. If you play the x game, 2 times negative 6 would be negative 12, and a negative 1, which would give you a factor of negative 4 and 3. Now, once you have those factors, let me see if I did this correctly. I would go to 4-term 2t squared minus 4t plus 3t minus 6. So I factor out 2t, and I have t minus 2 and I factor out plus 3. So I have 2t minus plus 3 times t minus 2. I don't think that I had it right before. Okay, now I would solve each of these for 0, zero product property. So 2t plus 3 equals 0. I subtract 3 from each side, so I get 2t equals 3, negative 3. T equals negative 3 halves. Then I have t minus 2 equals 0. Add 2 to each side and I get t equals 2. Why would this not be the correct answer? We're looking for the time that it takes for it to land. Why couldn't it be a negative 3 halves? Hopefully you're thinking because you can't have a negative time. That would be correct. So the time would have to be 2 seconds for that ball to land. Okay? Thank you very much.